In this video, we're simply going to look at Newton's laws. These are practice questions from the Physics 1010 tutorial sheet 3. And the first question is, a 45 kilogram woman stands on a spring balance inside an elevator. The scale reads the force with which it pushes upward on the woman. What does the scale read when the elevator is accelerating upward at 3.65 meters per second, and also at when it's accelerating downward at 3.65 meters per second? So we're simply going to have, so we have question 1. So let's take this to be our elevator. This is what we're having. Then the woman is here. We're going to use this box to represent the woman. So if the elevator is going up, we know to say initially this woman has weight, so her weight is equal to weight is equal to mg. Then there's a normal force because the elevator is in contact with her, so meaning there's a normal force somewhere there. Then because she's going up, to solve the first part, because she's going up, it simply means that the normal force is winning. So the normal force minus the weight should give us the mass and the acceleration that she's experiencing. We're simply using the second law of Newton that says the net force acting on a body causing it to move is always equal to mass and acceleration. So this is what we're having, and the normal force is just going to be equal to the mass, the weight, mass times gravity, and mass times acceleration. So this will just be, her mass is a 45. Then we know we are having 9.8 and we have 3.65 as the two accelerations. So m is common, and I just factorized m here. I've just done this, so it's the same as that. Then here, when you sum up this, so according to my calculation here, we're simply getting a 605.25 newtons. That's simply the net force that you're going to get, because the question is explicitly asking us to say, what does the scale read when the elevator is accelerating upward, right? So meaning, what will be the resultant net force that the scale is going to read? That's simply what we are interested in. Yeah, so we are factoring in the fact that there was weight and there was a normal force. So that's the reason why we are simply saying the normal force, since it's going up, it simply means that the normal force was winning as compared to the weight. So in other words, saying the winning force minus the losing force is always equal to ma. So this is what you're having. The same applies for part B. Part B, now they're saying this thing is going down. So this is just to check if you understand the whole principle regarding the second law of Newton. So here there is weight, the same thing again. Then we still have normal force there. Then we have what? This thing is going down and the acceleration is 3.65. So because we are going down, it simply means this is winning, meaning mg minus the normal force is equal to mass times acceleration. Then from here I can take the normal force this side and bring the ma this side. So this is going to be ma is equal to our normal force. That's what we are looking for. So here we're just going to say the mass is 45. This is 9.8, then minus the acceleration, which makes sense because it was going down, the acceleration has to be negative. So our normal force when this thing is going down, so because I'm using this calculator here, we'll just change this to be, so if we clear everything, we're having a 45 multiplying 9.8 minus 3.65 close. This is giving me a 276.15, something like this. This is what you'd get to be the normal force if it's going down. So this answers your question number 1. Okay, these are the answers there. So this is what you are getting. Let's see the calculator. It gave us what? It's a 75, not 15. Yeah, this should be a 75. So this answers your question number 1. Hope this is okay. We're just using the second law of Newton. Then look at the second one. The second question, they're saying, when a force of 450 pushes on a 20 kilogram box as shown, so we are pushing it at this point, by the way. Then they're saying the acceleration of the box up the incline. So this thing is going to go up on the incline. That's the direction. The acceleration is 0.7 meters per second squared. find the coefficient of the sliding friction between the box and the incline. So we're looking for friction. So because it's going up, we know already that there's mg sine theta. These are the well-known forces acting on this object. These are going to be a must. These we know. These are always there. These three here. So we said, if you check the video for Newton's laws, the recorded class, we said these three forces are a must. Okay, so we are having a 450 Newton force that was pushing the box up the incline, and the 450 is supposed to be resolved into x and y components. So aside from these common regular forces that we have, I'll just erase them to create space for you to be able to see us resolving the 450. So we're going to resolve the 450 in such a way that we're going to make this to be our angle. That's going to be our theta there. Then the 450 is being applied here. So the 450 can have an x component. So an x component, which is going to be in this direction, which is simply 450 cos 45, because we're going to use the same angle, because these are going to be alternative angles, right? Then we're going to have the y component, which is going to be like this, which is simply your 450 sine 45. So if I'm to write all the forces on the diagram, I'll just come here. So the 450 was not a normal force that is pushing this thing upward. It's different if they indicated it like this. Would have just taken it to be the way it is, but then it was at an angle, because you are seeing it's projected at an angle here. There's an angle here, which we're assuming to be the 45, because it was not stated. So now if we were to put or show all the forces that are acting on this object, on this box here, we're going to put the normal one, mg sine theta, and because they mentioned that we're looking for the coefficient of friction, meaning there's friction, there's a force that is pushing it this side, that's the 450, then cos 45. Then down here we are having mg, remember there's mg cos theta, and there's also another force trying to pull it down, also pushing it down, which is 450, then sine 45, that's what you have. Then we are having a normal force there. So these are all the forces that are acting on this box. But either way, we are told the direction. This thing is going up. So meaning the winning force is the 450 cos 45. That's a winning force. These two guys are losing forces. So we'll just come here and make up the equations. So we're on question number 2. So the first equation we're going to make is that we know friction is supposed to be equal to the coefficient of friction times the normal force. And from our diagram here, you are seeing that the upward force, which is the normal force, is equal to these two forces down, which is simply mg cos theta, then plus your 450 sine 45, which is your theta. So here we're just saying another expression is that mg, we are having what, mg cos theta plus your 450. Then we are having sine 45. Then we also know that the winning force was 450 cos 45. The losing forces are the two of them. There's frictional force and there is mg sine theta. Then this will give us ma, that's what we want. They told us the acceleration in the question. They gave us the acceleration to be 0.7. The mass was given to be 20. We have the force, which is 450 that we're already using. So here I'll just make the substitutions. This is going to be mu times the mass is 20. Then we are having the 9.8. Then we're having cos 45. Then plus, because here we're trying to make up the equation for friction, right? Normal force is this. So this whole thing here is normal force, I mean. So normal force, maybe if I was to calculate it here, if you punch everything, you have 20, 9.8, then cos 45, then plus your 450, then sine 45. If you punch everything, so if you punch everything here, you should be getting a 456 if I'm not mistaken, because I'm not using a calculator from a normal calculator. I'm using this guy here, so you can just verify what you are getting. So let's just try to punch this. We see, so we're having let's say your trig is what, cos 45. So Okay, so we clear everything. We're just saying cos 45. Okay, so cos 45 is giving us this expression there. Then we're simply multiplying it by, so we multiply it by 20, then by 9.8. This is what we are getting, then plus, when we say 450, then we say sine 45. Okay, not sure if this is going to be okay. So this is giving me wrong things. So I'm getting a 4. Let's just take it as 456.8 to be true. That's the normal force that I'm getting. Then we're just saying we are having a 450 cos 45, then minus the force of friction is mu times the 456.8, then plus the mg, which is 29.8, and sine 45 again. This should give us mass is 20, and the acceleration is 0.7. That's what we have. So here we can just express this as a function in terms of mu. That's for 456.8, then minus, this is 29.8, then sine 45 is equal to 20 by 0.7. That's our acceleration. So here we can make mu the subject. So if you try to make mu the subject, this is going to be 456.8 mu, which has a negative, is equal to, you have this is going to be 14, then this is going to be minus 450 when it goes this side, then we have plus 20, then you have sine 45, divide this side by 456.8, even this side by negative 456.8. Here you get your mu to simply be the same with the one that you have on your answer. So this is what you should basically get. This is going to be your answer. So remember that the tricky thing here was just on the 450, but all the equations just follow through the second law of Newton to say the winning force minus the losing forces is equal to ma. Then these are the substitutions that we made, making sure that we equate the forces in the x and also subtract the equations in the y. So that's basically what we had. Yeah, so this is basically what you have. Identifying the forces is the most important thing under Newton's laws, because that is going to help you to create the correct equations. So here we said this minus this 2 is equal to ma, then n is equal to the downward forces. So this is basically what you have on question 2. Now look at question number 3. So question 3, they're telling us that the rear side of a truck is open and a box of 20 kilogram is placed on the truck 4 meters away from the open end. If the truck starts from rest with an acceleration of 2 meters per second squared on the straight road, find the distance the truck will travel when the box will fall off the rear, given that the friction between the tarmac and the whole thing is 0.15. That's what we are given. So here we're just saying the distance before this thing falls off here is the 4 meters that is given there. And when these guys are moving initially, because here they're saying the rear side of a truck is open and a box of 20. So this is the guy that's moving. It's placed 4 meters away from that. So the only mass we are given is the mass of the box inside, the 20 kilogram. So we can first of all start by getting the force that is causing this to move. So the force that we're going to get is simply ma. So the force is going to be 40 because we're having 20. The acceleration was given here to be 2. So this is what we are getting. The force is what? Is 40. That's the force responsible for it to move. Now, if there is friction, now, so they're saying on a straight road, find the distance the truck will travel when the box will fall off the rear. So now, when it's now moving, there's friction that is being encountered. Yeah, so initially the 40 was not with respect to friction, but now it's moving. So there's friction involved. So we're just going to say the force that it is moving with minus the frictional force is equal to MA, that's what we are having. So we know to say the frictional force is going to be, so the force that we are told to have, so the force we are having is simply a 40, so we already have a 40. The force of friction, we have the mu to be 0.15, then we multiply it by the normal force. Normal force is just going to be, normal force will be the same as weight, which is mg, 20 times 9.8. So this will give us 20 times 9.8. Then the mass is 20. We're looking for the new acceleration when friction is now factored in, right? So that now we can get the acceleration is going to be 0.53. That is the acceleration when friction is factored in. So this is what you're going to get. So we got the force that the box is moving with without friction. Now we are getting the acceleration when friction has been factored in. So now that we know the acceleration when there's this friction that it is encountering, because what the truck is experiencing is the same thing that the small box inside is also experiencing. So here now we have to get we are done with getting our acceleration. This is on question 3. We've gotten our acceleration when there's friction, which is simply 0.53 meters per second squared. We're simply going to use the equation for distance to get this. This is going to be this equation. So we just plug it in because initial velocity, it was at rest. They're saying open this. From this, it starts from rest. So the initial velocity is 0. So meaning this is 0. We don't have the time. Do we have the time? No, we don't. Yeah, so we don't have the time. The distance that it moved first was 4. So we have, this is going to be, we don't have the time. Then we have this. The acceleration it was moving with is 0.53. We're trying to use this equation to get your time. So this is going to be 0.53 t squared. Divide by this. Then we cancel here and square root. So we'll get our time. The time you're going to get will be 3.885 seconds, something close to this. Now that we know this time, we're going to get the distance that it had in the 2 meters per second squared. So the initial thing, the acceleration of the track is this, right? So there are two things here. There is the box and the track. So the acceleration that we're from getting, the 0.53, was for the box. Now we're trying to get the distance, because the distance of the box is 4 meters. We know. Then the distance, how far will the track move until this thing here falls or covers this 4 meters distance for it to fall. So we are looking for the distance that the track is going to move. So the acceleration of the track was given to be 2. The initial, so I'm supposed to use this equation, but then initial velocity is 0, so no wonder I'm ignoring this part. The acceleration of the track is 2. The time that the box takes to drop off is the same time that it takes for this thing to reach a point that we're interested in. How far does the track move until the box falls off, right? So the time is the same. So no wonder we're using this. When you do this, you get your 15.1, something close to what you have in your solutions. So that's how they got this solution there. So we first of all calculated the acceleration of the box with respect to the friction it's experiencing. Then, because we're not given the mass of the track, we have to use the acceleration of the box to get the time that the box took for it to fall off in this 4 meters distance. Then once we knew the time it takes for it to fall, we'll know the time that this guy is going to stop, because this guy, the track only stops after the box falls off. Yeah, so after we got the time, which was 3.8, now we used it with the acceleration of the track to get the distance that the track had covered. Yeah, so this is basically how the question was supposed to be handled. Hope this is okay. So to test your skills further, you can actually be pausing the video you attempted before you see how we're going to do it. So look at number 4. Number 4, they're just saying 2 blocks with masses 3.2 kilogram, mass 2, which is 4.1 kilogram, are touching each other on a frictionless table. If the force F is equal to 6.8, what is the acceleration of the 2 blocks, and with what force does M1 push against M2? So these guys are connected. So they're saying this is simply going to be treated. So we did this in the examples. If you check on the channel, there's a separate video where we're doing applications or examples on Newton's laws. So we're saying there's a force that is pushing these two boxes. These two boxes are coupled. So under coupled objects, there's M1, then there's M2. The force that is causing them to move, we can simply take them to be one thing. That's M. This is what you're having. So they're being pushed by the same force, which is 6.8. 6.8. The masses can be added. So if we add the masses, that's 3.2, and or rather plus 4.1, and acceleration. So we can divide by this 4.1, even this side 3.2 plus 4.1. So meaning we can get the acceleration. When you do this, the acceleration will simply be we're having a 6.8 on top divided by 7.3. This will give us 0.931. Hope you are getting the same when you punch. So this is what you get. Now, if this is the acceleration that they are both moving with, there's a tension that is pulling this guy here. There's a tension in between here. So we're just saying for the box to move at this acceleration, we'll take the second box for instance. For it to move, it's being pushed by 6.8, right? And it's moving with this acceleration, but it's pulling the other guy. Let's call this force to be tension. So we're going to say 6.8 minus the tension is equal to our acceleration 0.931, then multiplying the mass, which is a 4.1. So we can take this on the other side, that's 6.8 minus 0.931 times 4.1 is equal to the tension. Because they are pushing each other with respect to M1, the tension is causing M1 to move. But with respect to M2, the tension is happening in the opposite direction, because according to the third law, to say for every action there's an equal but opposite reaction. So the force here is just going to be the tension is equal to, I'm using the first one here to get our tension. So our tension here is going to be our 6.8 minus, so we are having a 0. Okay, so we got the acceleration to be this value here. That's what we got. There is 0.932. Then if we are looking for, they're saying with what force does M1 push against M2? So the only way to get that is simply by multiplying M2 by the acceleration that we are having. In short, what's the disturbance that M2 is having because of M1 being close to it? So here, if I'm to show you, we're just going to say our 4.1. The easiest, not the previous method I was explaining, is just by multiplying this with 0.931, the guy that we got. So this is how we are getting the 3.8. This is what we get here. That's the force with which M2 is being inconvenienced. This is what you're having. Then if we switch this, they're saying repeat A and B if F is in the reverse direction. So if it's in the reverse direction, meaning we're going in the other way, in the other direction, meaning our acceleration will be the same but just negative, because acceleration is a vector, and whenever you change, you're going in the negative x direction. This is going to be done in a similar way, except now we're going to say we're going like this. So we're having negative 6.8 is equal to the mass, the two masses. When you add them, they give you a what? They give you, that's a 7.3 is equal, multiplying MA, then you do this. Yeah, so you get your acceleration to be the same but now negative. That's what you just have. Then once you get this, they are saying pushes on M2 rather than on M1. So the force that this guy is feeling, this is just going to be in a similar way. We simply let me just use my calculator here to just verify this. This is going to be 0.931, then multiplying 3.2. This is going to be 2.98. This is what you are getting. So this is why the answers are like this. So that answers your question number 4. It's very simple. We're just trying to look at coupled objects. We're still using the second law of Newton. just under coupled objects. So if this is really confusing, there's a separate video that explains the principles and proper examples before we even come to the tutorial sheet. So this should be a surplus for those that have already studied the topic. They just need to confirm their working. Then look at question number 5. Question number 5 was interesting because they are saying the force F in the figure pushes a block of mass, capital letter M, which in turn pushes a block of mass, small letter m. There is no friction between M and the supporting surface. So there is no friction between capital letter M and the table. There is no friction there. If the coefficient of friction between the two blocks is mu, so on the here, that's why there's friction between M capital letter and M small letter. That's when you can experience friction. How large must F be if the block of mass M is not to slip? So we don't want this guy to slip off, like to move or anything. So we're just saying this thing has weight, right? It's hanging here, so I'll put weight. That's weight. Weight is equal to this. Then here I'm having what? According to where I'm seated, like looking at this thing, it's supposed to fall, right? It's supposed to fall because of its weight. Then we have what? Friction this side. Now friction happens to be equal to the normal force because here we're pointing up, so we're just saying if there is weight here, there should be normal force. But the normal force can only exist if there's what? If there is contact. So here we also have weight, the weight of this small letter. This is the weight here, and we also have normal force there. Then this big thing also has weight, right? So we can just first of all say the force, this force here, capital letter F, is the same as the capital letter M, and also this. Then this is going to be the first equation that you make. This will be the first equation. Now, if this is the equation that we have, and we know to say, according to this expression here, the only force acting on it is the weight, and we're just going to say the weight, which is mg, should give us what? This is going to be the frictional force, which is just mu. So we are saying this guy here has to be equal to, how can we say this? So look at question number 6. They're saying a block takes twice as long to slide down an inclined plane that makes an angle of 35 degrees with the horizontal, and it simply falls freely through the same vertical distance. What is the coefficient of friction? So we're looking for mu. So here they're just saying that it takes twice as long. So the time it takes here to fall on the incline here, that we have, takes twice as long to slide down the incline plane. So here it takes twice as long. So here, if time is, let's say, 4 seconds, here it will take 2 seconds for it to fall in this height h. So we're going to create equations that involve friction and the force that we always know. So here we can use your sine theta first to be equal to opposite over hypotenuse. So we know this expression. We're saying sine 35 is just equal to the height over the x. That's what we have. Then we know to say there is mg, which is causing this mg sine theta, causing it to move down because it's coming down. There is mu, implying that there's friction. Then we know there's mg cos theta there, and there's the normal force. So the first equation we're going to write is that the normal force is mg cos theta. Then we can get the frictional force. The frictional force is the 0.16. We don't know it yet. We're looking for the coefficient of friction, right? That's the guy that we're looking for. This has to be the answer. So we're saying mu times the m. We're saying mg, so we don't have the mass. Mass is not given, meaning it will cancel out somewhere. This is what we have. And the equation that we make is that mg sine theta minus this frictional force, mu mg cos theta must give us what? Ma. That's the first equation we make. And you notice here mass will cancel throughout. No wonder they didn't bother giving us mass, because it's still going to cancel out. So we're having mu, then g, then cos theta is equal to the acceleration. So this is the first equation that we can create. That's what we have. So according to my calculation here, if you punch this, you are getting this to be the first expression for the acceleration. Now we know to say if it takes twice for it to, this is on the incline, this is what you're having, this is on the incline. Then in the vertical, we're also supposed to form an equation. So in the incline, which is the distance covered being x, we can just say for us to cover x, the initial, this was from 0. So we're just going to say half the acceleration, then say t1, we're going to call it t1. This here would give us the distance on the incline. This is what we're going to get. And we know to say we can replace here. So we're saying wherever there's the distance here, we're saying x is the same as half. Where there's acceleration, we can put this whole expression. That's 5.62 minus 803, and the mu, then the t1 squared, that's what we have. Then we have in the vertical, we're saying the height that we should cover. So here, this will just simplify our working. So we are from getting the expression that is in terms of t, t1. This is the expression I'm from writing. Then if you substitute, because we're saying x is equal to half, then at squared t1. Where there's t1, where there's a, we can put this whole expression. When you put it, you get an expression that looks exactly like this. So here is our solution. We are getting this expression. Now we are told that this time here is twice as compared to the time that it moves in the vertical direction. Yeah, so we're going to create an equation for h. And we know what h is because we created this. We said sine theta is the same as h over x, meaning h is simply x times sine 35. That's what you are seeing here. That's a 0.57. So the distance for it to fall in the vertical in the h is simply going to be, we are having, because the initial is also 0, the initial velocity is 0, so we're just going to have this. Then we have, it's falling down, so acceleration is g, the time is t2 squared. This is what we are going to create, and where there's h, we are putting x. This here is simply x sine 35. This is where the 0.57 x is coming from. Then we have this time here, this part here, which is gt2 squared. Now we know to say t1 is simply the same thing. So first of all, we can say t1 is twice as compared to what? To t2. So if I square this side and I also square this side, It's supposed to be the other way around because T1 is big. Yeah, so meaning we have to make them equal. We can use this because we said the time it takes for it to fall is 2i. So here, if it's a 4, meaning here it's going to be a 2. How do we make these guys to be equal? Is by multiplying this by 2, right? That's what I'm simply doing here. So we're multiplying T2 by 2. So that when you square this, we're saying T1 squared is the same as 4 T2 squared. This is what you are seeing here to say these two guys are equal. And if we equate the two expressions that we got, we have this expression here, and we equate it with this expression there. We solve them. Simplified, you're simply going to reduce it to this, and you are finally going to get your mu to be this. So you can just follow through to see how we're just making mu to be the subject of the formula. That's what you're going to get. You get your answer that was desired there. Then look at the next question. This question here is there's a video separate that we did this particular question. Let me just give you a guidance. Here we said the only thing that you need to do here is to identify the direction this thing is going to go in. Down here on the incline, here we have mg sine theta, we have tension there, and we have friction as well, and here we have tension and there's friction as well. So we made two equations after we split this on the middle. We said according to B, mg sine theta is the winning force minus the tension minus the frictional force is equal to ma. Then according to A, we say tension minus the frictional force is equal to ma. Then according to A, the frictional force is just equal to mu and mg. That's what you have. According to B, the frictional force is just equal to mu mg cos theta, because this is on the incline, this is just on the plane. Then we solve these two. That's how we got our acceleration and our tension. So there's a video that says application to Newton's laws. We did this exact example, so you can just check through. And okay, this marks the end of tutorial sheet 3. Thank you so much for watching. If you have any questions, please feel free to reach out. Then I'm going to also upload the video for projectile motion, which is tutorial sheet 2, and also vectors, which is tutorial sheet 1.